Welcome to our presentation of nanoparticle solar cells, presented by Tay Holzhaus, James Laprecido, Cameron Eschenberg, and Grace Abbott. What type of nanoparticles are used? The nanoparticles that are used in this experiment are silver, gold, platinum, and copper. They were used to influence the efficiency of silicon-based solar cells. Based off of the previous scientific experiments that they have found, the best size of nanoparticles that should be used should be in the range of 15 to 20 nanometers. The most accurate data that could be received is using these sized particles. Here you have pictures of each particles and what they look like and the shapes of them. So gold has a spherical shape at 20 nanometers because they change based off the nanometers, and this is what they look like at 20 nanometers. Platinum has cubic at 20 nanometers, and that's what they look like at that size. Here's copper, and they're spherical, and that is what they look like at 20 nanometers. And here's silver, and it is cubic, and this is what they look like at 20 nanometers.
Okay, how are the nanoparticles used in the application? So the solar cells are an innovation of renewable energy, and solar cells use light, and it converts the light into energy by the photovoltaic effect, which basically photovoltaic cells are solar cells that are dependent on the shining light, and then depending on how the light shines through it, the light is either reflected, absorbed, or it passes right through the cell. So there's been a lot of recent discovery using solar cells which involve nanoparticles, and nanoparticles in the solar cells increase the efficiency of them and as well as help the currents and voltage. So in this application, the nanoparticles absorb infrared light and emit light in the visible spectrum when the nanoparticles are illuminated. And also the nanoparticle electrons have the same vibration frequency as the electromagnetic wave in the absorption part of the solar cells. So that means if you can change the spectrum of light, and then that in turn increases the efficiency of the solar cells and not the resonance phenomenon. So the particles were tested with gold, copper, silver, and platinum. And nanoparticles are great for reusable energy because reusable energy is an upcoming resource in the future. And then photovoltaic cells are also semiconductors, so that means that they can conduct electricity pretty well.
Now, what do nanoparticles actually do? Hi, I'm James Laprecido, and the answer is really quite interesting to that question. These nanoparticles, being platinum, silver, gold, and one other, copper, thank you, were used in silicon solar cells in order to increase their efficiency and production of energy. While in the dielectric layer of the silicon solar cells, the length of a nanoparticle can change the spectrum of light. This is shown by figure 2, right here, showing wavelength versus the amount of light absorbed. While all nanoparticles increase the efficiency, platinum had the greatest effect on the absorption of light. As seen right here, platinum is the yellow one right here. You can see it has over a, 3 absorption spectra above all the others. Now, in addition to that, in testing, it showed that platinum nanoparticles had effects on the efficiency of voltage in silicon circuits as well, increasing the current by 2.28 times. In conclusion, nanoparticles have positive effects on the efficiency of silicon cells. However, platinum has properties that make it perfect for introducing into semiconductor optoelectronic devices. This is proven by the increase in absorption and the increase in current density shown by this graph right here.
So what current technology are these nanoparticles improving? They're improving the current solar panels that are used to produce electricity, and they're being worked on to increase the efficiency by 2 times. With the addition of these nanoparticles to the solar panels, researchers are looking to double the efficiency. This is because the nanoparticles have different effects on the solar panels than just the regular solar panels. They have a better way of absorbing the light in certain times and using it to transforming it into the power. The research that has been done has found 2 different times that these nanoparticles work best. The first is when the nanoparticles absorbs the infrared light and emits light on the visible spectrum. And the second is when vibration frequency of electrons in the nanoparticles are equal to the frequency of electromagnetic wave. This causes the nanoparticles to work better in the certain end regions of the solar panel, which is just like the way the solar panels are made. There are there's N++ and N+, and when you put the nanoparticles in them, they double the efficiency. And these are our references for our sources.
All right. Thank you for listening to our video, and we hoped you learned a lot about the effects of nanoparticles on solar silicon cells.